All the mathematics needs to be bottled up and delivered to people exactly like hyperbolica is done. I don't know if you've heard of this thing called aphantasia. It's basically a condition where about 4% of the population literally cannot mentally visualize anything. They can't voluntarily conjure up an image in their mind. For some people, you might be like, yeah, that's me. Yo, you're actually seeing things in your mind? Yes, that's all of us when it comes to math. We literally can't conjure up mathematics in our minds. And on the other end of the spectrum, there are folks that have what's called hyperphantasia. When they imagine things, they're as photorealistic as real things in the real world. When they think of an apple, like that apple from their imagination legit looks like an apple that you might pick from a fruit store. When it comes to math, we want to get people to be hyperphantasiacs. I think you don't get there with this. What I think is a better way to get people to become hyperphantasiacs for math is through using video games. This is just shorthand for the actual visuals that should be happening in your mind. But it's hard to visualize something that you're not being shown a visual for. So what I think we need to do is use video games as that prosthesis or the training wheels that provides the visual for you. But over time, as you play more and more of the game, you then get to a point where you don't need this anymore. You can take the training wheels off. You can remove the game and you can just render and play this in your mind. You at that point become a hyperphantasiac for mathematics. And so people have asked me in previous videos where I've talked about this idea of teaching math through video games, like, bro, like, okay, like, you're just talking in the abstract. Show me an example of what this looks like. The problem is no one has made these games. There's very few people that I think have done it well. I will say though, there is one game that I have seen where they're doing this so well. And so it's this game called Hyperbolica. So in this game, Hyperbolica, the person that designed it was frustrated with how an area of mathematics called non-Euclidean geometry was being taught. What is non-Euclidean geometry? Non-Euclidean geometry is geometry that breaks all the basic rules of geometry we learned when we were like in middle school, such as when you look at a triangle, the internal angles add up to 180, or a straight line is 180 degrees. What this game does is it literally drops you in a world where the fabric of that reality is curved. It's as if you were a baby that was born into a world where the physics of that reality is no longer Euclidean. And so it takes basic puzzles where there might be like a basic puzzle and say, walk straight. And so you might be like, alright, dope. And you might just walk. And you might like, you might curve. Essentially, it just builds puzzles in this world where the basic facts of geometry are just completely different. And through playing and solving puzzles in this world, over hundreds and hundreds of hours, you build an intuition for what it's like to exist in the spherical world. That's what we need to be. That we need to teach people at that level. All the mathematics needs to be bottled up and delivered to people exactly like hyperbolica is done. I'm curious to know for some of you out there, when you're doing mathematics, if you're doing it at all, like are you shuffling around symbols on a piece of paper, or are you actually like rendering these like fantastical worlds in your mind? Because we need to get more people to that. I'm tired of this being how mathematics is marketed to the world.